So in chapters 1.2, applications, I would like you to review the section on pages 113 through 119 of your book. We are going to be solving one linear equations in word problems and applications. In this section, I'm going to be looking at geometric problems, money problems, problems of motion, and finally mixture problems. So our first objective is to look at a geometric problem. This is on page 121, number 19. A contractor must tile a rectangular kitchen that is 4 feet longer than it's wide, and the perimeter of the kitchen is 48 feet. So we have to have the strategy, and so you have to know some geometric formulas. One formula that you need to know about is perimeter, and the perimeter of a rectangle is equal to twice its length plus twice its width. In this case, the perimeter is 48 feet. So we're going to find the dimensions of the kitchen first, and then we're going to find how many square feet of tile should be ordered if the contractor needs to add an additional 10%. And there's a formula that we will be using. The strategy is the total is equal to the area plus 10% of the area. And then finally, we're going to determine the total costs if the costs are $12 per square foot, and we're going to add the sales tax along with it. So in part A, we are going to look at first drawing a picture, and we've drawn a picture. The length is 4 plus x, which is the length, and the width is x, so I put that into my formula that I have. 48 is equal to twice the length, which is x plus 4, plus 2 times x. In this case, I'm going to divide both sides of the equation by 2, and I get 24 is just equal to 4 plus x. I combine the x terms. I get 24 is equal to 4 plus 2x, so that means that 20 is equal to 2x, and so that my dimension now is, the width is x is equal to 10 feet, so my dimensions of the kitchen are 14 feet by 10. So now in part B, I see that the area is equal to the length times the width, which is 14 times 10, which is 140 square feet. And so my total of tile area that I need is going to be the area plus 10%, which is 140 plus 0.10, which is 10% times 140. That gives me 154 square feet. Now I'm going to use that for my costs, and my costs are $12 a square foot. So it's going to be 12 times 154 plus the tax, which is 6% of the area, times 12. So it's 12 times 154 times 0.06. And I get $1,958.88 is the estimate for tiling the kitchen. So in solving our application problems, sometimes I draw pictures. For geometric problems, typically I draw pictures. For money problems and mixture problems, I usually have a table that I work with, and so I'll be using a table in this case to set up the information. So this is page 121 in your book, number 30. Ebony bought a 5-year treasury note that paid equivalent of 2.8% simple interest. She invested $5,000 more in a 10-year bond, earning 3.6% than she did in the Treasury note. If the total amount of interest from these investments was $5,300, determine the amount of principal for each investment. The strategy is the interest is equal to the principal times the rate times the time. So that's the formula that we're going to be using in this problem. I set up a table that has the category that I'm interested in, the principal, the rate, the time, and the total interest. So the category is 5-year and 10-year notes. One's a bond and one's a treasury note. X is equal to the amount of money I'm going to put in my principal for 5 years. I let that equal X. And then for the 10-year, it's 5,000 plus X. For the rate, I get 0.028 for the 5-year and 0.036 for the 10-year. The time is 5 years, obviously, for the 5-year Treasury note, and 10 years for the 10-year bond. So the interest is going to be 5 times 0.028, which is 0.14x, and the interest for the 10-year is just going to be 10 times 0.036 times the amount of the principal, which is 5,000 plus x. And they all have to add up to $5,300. So that's what I ended up setting up as my equation. 5,300 is equal to 0.14x plus 0.36 times x plus 5,000. I distribute the 0.36 through the parentheses, and I get the following. 5,300 is equal to 0.14x plus 0.36x plus 1,800. You will notice then that I can combine the x terms, and I get 0.5x plus 1,800 is equal to 5,300. And now I can subtract both sides of the equation by 1,800, and I get 3,500 is equal to 5x. I can divide by 0.5, it's 0.5x. I can divide both sides by 0.5x, and I get x is equal to 7,000. So the 5-year is going to be $7,000 I'm going to invest, and I'm going to then invest $12,000 into the 10-year. So here I have a motion problem. It's page 122, number 35. 2 passengers leave the airport at Kansas City, Missouri. One flies to Los Angeles, California in 3.4 hours. The other flies in the opposite direction to New York in 2.4 hours. With the prevailing westerly winds, the speed of the plane to New York City is 60 miles per hour faster than the speed of the plane to Los Angeles. If the total distance traveled by both planes is 2,464 miles, determine the average speed of each plane. So in this case, I drew a kind of a picture. You can also use a table here. But I had Kansas City right here, and I have 2 planes, one going in one direction and the other going to New York. I've got LA and New York here. And then I've got the information. I have the times up here, and then the rate. I have the rate is X for going to LA, and the rate going to New York is X plus 60. So I call you'll notice my strategy is the distance is equal to rate times time. So I have a distance going to LA, which I call D1, and I have a distance going to New York, D2. And I notice that D1 and D2 has got to equal to the total distance of 2,464 miles. So D1, if I multiply the rate times the time, I just get 3.4x for D1. For D2, I get 2.4 times x plus 60. And when I do the distribution property, I get D2 is equal to 2.4x plus 144. I put that into my formula up here, and I end up with the following. 2,464 is equal to 3x plus 2.4x plus 144. I combine the x terms. I get 2,464 is equal to 5.8x plus 144. I subtract 144 from both sides, and I get 0.58x is equal to 2320. And I divide both sides of the equation using the equality principle by 5.8, and I get x is equal to 400 miles per hour to LA, and that means that I go 460 miles per hour to New York. My final problem is to solve a mixture problem. This is page 121, number 32. A nurse mixes 60 cc's of 50% saline solution with a 10% saline solution to produce a 25% saline solution. How much of the 10% solution should he use? You will notice that I start out with a table, and my table is the category, the volume that is being used, the percent of saline, and the volume of saline. So in this particular case, my categories are 50% solution, 10%, and 25% solution. The volume is, I start out with 60 cc's. I'm going to add a certain amount of cc's to 60 to get a final solution of 60 plus x. Here's my percent solutions, 0.5, 0.1, and 0.25. I multiply the total volume times the percent of salines to get the volume of saline. So in the first case, half of the solution is saline. So half times 60 is 30 cc's of saline. 10% of the solution, 0.10x, is how much I'm going to add to the 30%. And then I end up with a 25% solution with x plus 60 cc's. So that's where I set up my equation. I have 0.25 times 60 plus x is equal to 30 cc's plus 0.10x of cc's. I'm going to drop the cc's, and I get 15 plus 0.25x when I do the distribution is equal to 30 plus 0.10x, and I end up on this side when I add 15, or I subtract 15 from both sides of the equation, and I subtract 0.10 from both sides of the equation, I get 0.15x is equal to 15. And then when I divide both sides by 0.15, I get 100 cc's. So the 10% solution should be at 100 cc's. So in this chapter, we have solved some application problems. All application problems, we usually either set up a table or we draw a picture to describe our problem. And that's really the first step in solving, is either drawing or somehow picturing what the problem entails and putting in the necessary information. The next step is to find the strategy to solve. In other words, what are the formulas that I need to solve the problem? And then once I do that, I just put the information into the formulas and then I solve. Well, that concludes chapter 1.2. Our next chapter will probably be chapter 1.4.